Greetings of the day, friends. Welcome to this presentation on Kubernetes architecture. Kubernetes is at the core of modern container orchestration, enabling businesses to scale and manage their applications efficiently. In this session, we'll take a closer look at its architecture and key components to understand how it drives scalability, resilience, and innovation in cloud-native environments. Before going ahead, I would request please subscribe to my channel for more videos related to Linux administration, VMware administration, various cloud administration, DevOps tools, and many more new technologies. So let's get started. Kubernetes, often referred to as K8s, is an open-source platform that automates the deployment, scaling, and management of containerized applications. It was originally developed by Google and is now maintained by CNCF. Kubernetes is built to support portability across on-premises and cloud environments, making it a cornerstone of modern DevOps practices. By the end of this presentation, you'll see why Kubernetes has become the standard for container orchestration. Kubernetes operates on a master worker architecture. The control plane, or master, is responsible for managing the overall cluster state and making scheduling decisions. Worker nodes handle the actual execution of containerized workloads. Communication happens through the API server, with each component working together to ensure reliability and scalability. Let's dive deeper into the control plane. The API server is the entry point for all interactions, ensuring commands are validated and executed. etcd acts as a consistent and reliable key-value store for all cluster data. The scheduler decides which node will run a particular workload based on resource requirements. Lastly, the controller manager monitors and enforces the cluster's desired state. Together, these components ensure the cluster operates smoothly. Now, let's look at the worker nodes, which are where applications run. The kubelet is the node agent that communicates with the control plane and ensures containers are running. The kube proxy manages networking, ensuring pods can communicate seamlessly. The container runtime, like Docker or Containered, runs and manages containers. Worker nodes are the backbone of Kubernetes, executing tasks as instructed by the control plane. In Kubernetes, the smallest deployable unit is a pod, which usually contains one or more tightly coupled containers. Kubernetes uses workloads to manage these pods. Deployments handle stateless applications. Stateful sets are ideal for applications requiring persistent state. Daemon sets ensure critical pods run on every node. Each workload type addresses specific application requirements, ensuring Kubernetes remains versatile. Kubernetes networking ensures seamless communication between pods and external users. Cluster networking allows pods to communicate across the cluster without NAT. Services provide stable network endpoints for accessing pods, with options like cluster IP, node port, and load balancer. Ingress manages HTTP and HTTPS routing for external access. Networking is supported by CNI plugins like Calico and Flannel, which extend capabilities such as policies and encryption. Kubernetes handles storage through a layered approach. Volumes provide storage specific to pods, like host path or MTDIR. Persistent volumes, PV, are cluster-wide resources for long-term storage. Persistent volume claims, PVC, allow users to request storage dynamically. Storage classes define the characteristics of storage, such as SSD or HDD. These features make Kubernetes highly adaptable for applications with varying storage needs. Monitoring and logging are crucial for maintaining observability in Kubernetes. Tools like Metric Server, Prometheus, and Grafana provide insights into resource usage and performance. For centralized logging, solutions like the Elk Stack and Fluented are widely used. Kubernetes also generates events that track activities, helping with troubleshooting and auditing. This robust ecosystem ensures administrators have full visibility into their cluster's health. Kubernetes offers numerous advantages. Scalability. With horizontal pod autoscalers and cluster autoscalers, Kubernetes scales effortlessly. Resilience. Self-healing ensures pods are restarted or rescheduled in case of failure. Portability. It works seamlessly across on-premises and cloud platforms. Extensibility. Kubernetes supports custom plugins and integrations catering to unique use cases. These features make Kubernetes the go-to platform for modern application management. Thank you for your attention. I hope this session gave you a clear understanding of Kubernetes architecture and its components. Now, I'd be happy to take any questions you have. Feel free to reach out later if anything comes to mind. Thank you once again.